Now we're considering the amount of effort required to illuminate two light bulbs. Notice that both knife switches are open, indicating that when I generate electricity, it's got no appliance to run, and thereby is not going to be making these illuminate. It's quite easy to turn the crank of the axial flux alternator. There's no load on the circuit. However, when I turn this knife switch to the closed position, turning the crank becomes a little bit harder. Plus, we get illumination. Notice when I turn the crank slow, I get a certain amount of illumination, and then when I turn the crank fast, I get more. Watch what happens. So that was relatively slow. And that was relatively fast. In both those cases, the first knife switch was closed, but not the second one. Now we're going to put an additional load on the circuit by closing this knife switch. The electricity I generate will thereby need to flow into this bulb as well as this bulb, thereby having two appliances on the same circuit. It takes considerably more effort to run enough electricity into the circuit to illuminate these bulbs. If I turn the crank faster, even with both of these shut, then I get more illumination. If I turn the crank slower with both of these shut, I get less illumination. So the first thing I want you to watch for is a slow crank and low illumination. Next, I want you to watch for a higher degree of illumination, and this is me turning the crank faster. What's fascinating is that when I am turning the crank and I take this switch and turn it up, all of a sudden the effort becomes easier because there is one less additional load on the circuit.